Welcome to the water quality standards under the edges of chemical process utilities. Now, before we go into detail, in the previous lecture, we have discussed about the various water laws. We discussed about the task of water governance. We discussed about the various challenges attributed to the water governance. We have gone through the concept of hierarchical governance, discussed about the cross curing and different aspects of water governance in Indian scenario. In this particular lecture, we are going to discuss about the various water properties, quality parameters for drinking water. Now, you see when we talk about the use of water either for human consumption, maybe for the drinking water, maybe for day to day affair, even for housekeeping, or if we talk about the water requirement for the various manufacturing sector, we need to look at what kind of basic properties we are looking in water. Like suppose if we are talking about the water for the human consumption, then definitely the water should be odor free or odorless, it should be color free. In case if it has any kind of a coloring compound or in case of any odors, then definitely the human perception says this water is not at all useful for the human consumption, especially for the drinking purpose. Similarly, if we use for any kind of household activities, then again there are certain criteria through which we need to fulfill before we use for those particular aspect. Similarly, if the water is being used for various manufacturing sectors, to overcome the various process complexities, the water must possess certain properties. Now, when we talk about all these properties, there must be certain categorization of all these properties. Then when we discussed about the different type of properties, then there must be certain quality parameters. Now, you see when we talk about the properties and the quality parameters, there must be certain optimum level. Now, beyond the optimum level if we go, then definitely the cost of that particular water will go on the higher side. So, all these aspects we are going to cover in this particular lecture. Now, when we discuss the various salient features of water, so water is an ideal solvent due to its unique physical and chemical properties, and it allows almost all kind of chemicals to get dissolved into it. Now, if a chemical is immiscible, then it can sometimes form a suspension or colloidal solution in water and turbidity may form. Now, water can dissolve both polar as well as non-polar solutes. Also, it is easily available and cheaper than any other solvent, and the supply of water is in abundance. The uniqueness of this particular water or compound, this enhances its use in different sectors as well as increase its susceptibility to get polluted, because it is universally available. So, any process can make it polluted. Now, in one case it is unreplaceable compound of life, while in other it can be home for several life threatening microorganisms and chemicals. It is a universal fact. Pure water does not exist naturally, neither it is good for consumption. It is just like it must possess certain kind of a mineral over it. So, it is just like that you can't take distilled water for the human consumption. Our body continuously requires some essential minerals from water to work properly. However, if these minerals are present in excess, then it can also cause some problem related to digestion and inefficient absorption of nutrients from food. So, you must have an optimum level for the various kind of minerals. Now, let us talk about the water properties, and there are certain basic properties which we need to address while having this particular concept into consideration. Now, one is that temperature. Now, as we see that in the science world, we all aware that water remains in the liquid form from 0 degree Celsius to 100 degree Celsius under normal pressure. Then dissolved chemicals or dissolved salts, organic or inorganic compound. So, the color odor, toxicity and utility depend on various kind of dissolved chemicals. Another important thing is the suspended particles. Now solid particle of very minute size, usually not less than 0.45 micron, can remain suspended in water, and some physical properties and acceptability of water depends on number of suspended particles. So this sometimes they may cause the turbidity, and if it is the turbid, then again the perception says that we can't use that water for our day-to-day affair. Then microorganism. The presence of microorganism is a quality indicator of water, and its potability depends on this particular property. Nutrients. The presence of nutrients is very common in natural surface water and in water discharge after human use. The high level of nutrient is considered as a pollutant. So that means again the issue of optimization come into the existence. The quality of water is a prime concern for industries, especially for water supply, food, beverages industries, pharmaceutical industries, etc. And that needs the potable water for their production or high purity of water for their production, because it requires the mass scale consumption, and any kind of disturbance in the water quality or mismanagement in the water quality may become dangerous. Now other industries, apart from this, we discussed that they use the water for various purposes like heating, cooling, cleaning, manufacturing, steam generation, firefighting, etc. Drinking and sanitary use of water are also concerned for all industries, because they are liable to extend the water, sanitation and hygiene, and sometimes refer as WASH, this facility for their employees. Industry also deliver water to industrial colonies and township, basically useful for the drinking as well as housekeeping purposes. Irrespective of the quality of water that industries take in, they are always responsible for the quality of the discharge of they contribute to the environment, because everywhere we are talking about the water reuse, water recycling, and sometimes if the contaminated water become the part and parcel of the aquifer, then again it may create a problem. So that is why to overcome or to reduce the load on the water treatment plant, they must the industries are responsible to maintain the appropriate quality of the discharge water. Water quality is also a major concern in agro-based industries, because pesticides and fertilizers, they are applied in the forms belonging to the supply chain of the food and beverages industries, and sometimes they may become part and parcel of the groundwater too. Now every industry has the responsibility of supplying safe drinking water for their staff or employees living in their industrial campuses. Water supply industries, beverage and medicine or pharmaceutical manufacturers, they need the purified water that meets the potable standard or sometimes in ultra pure state. They need to maintain the drinking water quality standards for their raw materials as well as for their products. Now let us talk about the quality parameters for drinking water. Now there are many sources of water quality criteria and standards. Each country has its own standards and guidelines. Now these guidelines do not vary widely from country to country. However, in many countries they have adopted guidelines for other countries or organizations to frame their own standards. Water quality not only influences the water strategy for the business, but also impacts capital and non-capital investment in the water sector. Now when we are talking about the quality parameters, then question arises that how we can classify these quality parameters. Now these may be classified based on organic or inorganic according to its biological properties, then physical or chemical that is purely based on its physical and chemical properties, potable or non-potable, that depends on its use for human consumption, hazardous or non-hazardous, based on its effect on human health and ecology. Now, let us talk about the microbiological contaminants. Now, there are large number of microorganisms which live in water either permanently or for a certain period during their entire life cycle. There are various diseases those who are attributed to the microorganism. So, disease causing microorganisms are commonly classified as coliform or Staphylococcus bacteria. Industries do not generally discharge these organisms to the environment, but lack of proper wash facility in the industrial environment may cause health hazards. So, when we talk about the microbiological contaminants, one contaminant is the coliform bacteria. The source of this particular bacteria, when we talk about this, then one of the major pathogenic pollutant in water. It originates in human and other warm-blooded animals and goes into water through feces. Non-faecal bacteria, if present in water, serve as indicator for the presence of other forms of bacteria that may cause disease. Most common indicator bacteria are E. coli, which is a subgroup of coliform bacteria in water, which is generally measured to find presence of pathogenic bacteria in water. Potential health and other effects. Bacteria cause polio, cholera, typhoid, dysentery, infectious hepatitis. To name a few, list of the bacterial infection is virtually endless. Another is the contaminant is pathogenic Staphylococcus. Now, sources, it is kind of pathogenic microorganism found in sewage contaminated water, bath water like swimming pool, etc. The potential health and other effects, these are causes a wide variety of diseases, notably skin disease and food poisoning. Now, there are various physical parameters need to be addressed. The physical parameters may or may not relate to the industrial pollution. Now, these parameters relate to potability and suitability of industrial uses. Physical parameters also quantify the aesthetic value of water. Change in the physical parameters due to anthropogenic activities may adversely affect aquatic ecosystem. One of the physical parameter, or one of the most important, you can say, the physical parameter is turbidity. This is caused by the presence of suspended particles such as clay, silt and inorganic matter. Dissolved iron hydroxide, this can cause the turbidity when oxidized to insoluble ferric oxide. It is measured in terms of amount of light transmitted through the water sample. There are various potential health and other effects attributed to this turbidity. Basically, it is objectionable mainly for the aesthetic reasons. Another is the total suspended solids, sometimes referred as TSS. Now, when water with high turbidity is to be processed for use, then another parameter needs to be measured, that is called the total suspended solids or TSS. It impacts aquatic environment by restricting penetration of sunlight. Another important physical parameter is color. This can be caused by the decomposed organic matter and mine waste, etc. Because it's, again, I talked about previously that if the water is having certain coloring compound, then again it's highly objectionable and people don't like it. There are certain health and other effects like this mine waste may be toxic to the human and aquatic life. So, proper analysis of all these coloring compound must require before it can be used for potable purpose. pH. Natural water generally has the pH from 4.5 to 10. Now, if the pH of water is above 7, it is called alkaline. Best suitable pH range of human consumption or aquatic life or industrial use is from 6.5 to 8.5. The pH of water determines the solubility, that is the amount that can be dissolved in the water, and biological activity, which is referred that amount that can be utilized by the aquatic life, or the chemical constituents such as nutrients like phosphorus, nitrogen, carbon, etc., and heavy metals. High pH causes a bitter taste, water pipes and water using appliances become encrusted. Low pH also imparts bad taste and it can corrode the metals. Then odor. Again, if we are using the potable water for the drinking purpose, it is perception that it must be odorless. So, odor is an indicative of organic waste and decomposed matter. Bad odor or off odor water is unfit for human consumption. Then next is the next physical parameter is the taste. Now, some organic salts impart taste without causing foul smelling. Now, the bad taste or off taste, this makes water unfit for human consumption. Another physical parameter is salinity. Now, this relates to tidal water or water which has the hydraulic interface with seawater. Seawater has the salinity as high as 35,000 milligram per liter. Now, high salinity makes water unfit for consumption and it creates a various problem, and if we are using this particular water for industrial purpose, it may cause corrosion. Another physical parameter which is very important, that is alkalinity. This is the measure of the presence of bicarbonate salt in water. It is also the measure of the buffering capacity of water or the capacity of a basis to neutralize acid. Now, there are various things which we need to address pertaining to the health and other effects. So, not a health hazard, it does not possess any kind of a health hazard, but unsuitable for industries because of the corrosiveness. Electrical conductivity. This is the measure of chemical properties of water. It is the measure of the capacity of water to transmit the electric current through it. Now, fresh water assumes conductivity due to the concentration of ions in water which comes from dissolved salt and inorganic materials. The commonly used unit for measuring electrical conductivity of water is microsiemens per centimeter. It is not a definite indicator of water pollution, but an indicator of suitability of water for either domestic or industrial or agricultural purpose. Hardness. Hardness is caused by due to the presence of certain dissolved salts. The compound responsible for developing hardness in water, they are generally salts of calcium and magnesium. Hardness is measured by the amount of calcium carbonate expressed as milligram per liter of calcium carbonate. Now, this decreases the leather in formation of soap, increases the scale formation in hot water heaters and low pressure boilers at high levels. Now, the general guidelines for the classification of waters, especially with in reference to the hardness, that is 0 to 60 milligram per liter, as the calcium carbonate is classified as soft, 61 to 120 milligram per liter as moderately hard, 120 to 180 milligram per liter as hard, and more than, if the water is having the hardness more than 180 milligram per liter, is very hard, and that is based on the WHO guidelines. Now, there are certain organic chemical pollutants. Now, organic chemicals are mainly industrial products used as pesticides, herbicides in agricultural and in textile industries. These are harmful chemicals with long term effects on human health. So, a due care is needed while addressing such kind of chemicals in various aspects of life. Now, let us talk about, in this particular table we have discussed about the contaminants and different type of sources attributed to it and health effects. Now, if we talk about the acrylamide, this added to water during sewage and wastewater treatment. So, that is a source. And the health effects attributed that nervous system or blood problem increased the risk of cancer. So, over the period of time one may experience this dangerous aspect. Then benzene, this discharges from the factories, leaching from gas storage tanks, landfills. I mean, the use of the benzene is enormous. It may cause the anemia. It can decrease in the blood platelet counts. It can increase the risk of cancer. Then dioxin 2378 TCDD. The emission from the waste incineration and other combustion discharge from the chemical factories and sometimes the insecticide or herbicides production units. It can create a problem of reproductive difficulties and again attributed to the enhancement of cancer. Then alchlor, atrazine, diquat, endothal, picloarm, simenzine. Sometimes they are from the runoff from the herbicides use or insecticide use. It may create a problem of cataracts, stomach and intestinal problems, liver problems. Sometimes it may create the problem with blood, increased risk of cancer, cardiovascular system or reproductive problems, etc. Then benzene, pyrenes, the leaching from lining of water storage tanks and distribution lines. This again may create the reproductive difficulties and again they may increase the risk of cancer. Then epichlorohydrin. This is the discharge from the industrial chemical factories and impurity of some water treatment chemicals. This can increase the cancer risk and over a long period of time one may suffer the stomach problem. Then ethyl benzene, it can be discharged from the petroleum refineries and it may create the liver or kidney problems if somehow it can go into the body system. Then lignine, this is runoff or a leaching from insecticide use on cattle, lumber gardens. Again the liver and kidney problems may be attributed for this particular chemical. Then methoxychlor, this is a runoff and a leaching from insecticide use on the fruits, vegetable, alfalfa, livestock. Again it may create a problem with respect to the reproductive difficulties. Styrene, basic ingredient of various rubber and plastic manufacturing units. So, discharge from rubber and plastic factories, leaching from landfills. Again the liver, kidney, circulatory system problems, it can be attributed to the styrene. Then toluene, again the integral use of toluene in the petroleum factories. It can create a problem to the nervous system, kidney, liver, etc. Then vinyl chloride, again the integral part of polyvinyl chloride pipes. So, leaching from the PVC pipes, discharge from the plastic factories. It can increase the chances of cancer. Now, let us talk about the parameter indicative of environmental pollution. Now, there are some parameters of water quality which are measured as a pollution indicator and not as pollutants. By testing these parameters, it may be determined whether the water is linked with the potential source of pollution or not. One is the biological oxygen demand, BOD. the commonly known as BOD. Now, BOD is defined as the amount of dissolved oxygen needed by aerobic biological organism in a body of water to break down the organic material present in a water sample at a specified temperature and a specified period. The biological oxygen demand value is most commonly expressed in milligram of oxygen consumed per liter of sample during the 5 days of incubation at 20 degrees Celsius, and is often used as a surrogate of the degree of organic pollution of water, BOD 5. Now, this BOD can be used as a gauge of effectiveness of wastewater treatment plants. It is listed as the conventional pollutant in the United States Clean Water Act. Now, BOD is similar in function of COD, that is the chemical oxygen demand. In both measures the amount of organic compound in water. However, the chemical oxygen demand is less specific since it measures everything that can be chemically oxidized rather than just levels of biodegradable organic matters. So, let us talk about the chemical oxygen demand. Now, the COD is the estimate of oxygen required for the portion of organic matter in wastewater, and that is subjected to oxidation, and also amount of oxygen consumed by organic matter from boiling acid potassium dichromate solution. Now, COD is a water quality measure used not only to determine the amount of biologically active substance such as bacteria, but also biologically inactive organic matters in water. Now, in a BOD test, only biologically reactive carbon is oxidized, while in COD test all organic matter is converted into a carbon dioxide. The test for COD does not identify the oxidizable material or differentiate between the organic material and inorganic material present. Similarly, it does not indicate the total organic carbon present. The COD test, when we talk about the COD, how to analyze and what is the protocol for the COD. So, the COD test can be performed in 3 hours against 5 days requirement for BOD 5 test. Therefore, it is very useful. The COD test has the advantage of non being subjected to interference from toxic materials. The COD test is often used in conjunction with the BOD test to estimate the amount of non-biodegradable organic material in wastewater. Another important parameter is the dissolved oxygen, and sometimes referred as DO. So, the dissolved oxygen is the amount of oxygen that is present in water. Water bodies receive oxygen from the atmosphere and from aquatic plants. Running water such as that of a swift moving stream dissolve more oxygen than the still water of a pond or lake. Now, low level of oxygen, sometimes referred as hypoxia or no oxygen level anoxia, this can occur when excess organic material such as large algal blooms, they are decomposed by the microorganism. Now, during this decomposition process, the dissolved oxygen in the water is consumed. Low oxygen levels often occur in the bottom of the water column and affect the organism that live in the sediments. Now, as the dissolved oxygen level drops, some sensitive animals may move away and decline in health or even die. Now, dissolved oxygen level below 3 milligram per liter are of concern, and waters with the level below 1 milligram per liter are considered hypoxic and usually devoid of life. So, at last in this particular lecture we discussed about the water management criteria, water quality indicators, we discussed about the various parameters, those referred about the water quality etc., and may be useful for assessing the water quality. For the convenience we have enlisted 4 different references, and if you wish to have a further reading or further knowledge, you can refer these references. Thank you very much.